Welcome back. We're going to talk about the second derivative test now. It's a convenient tool to check for max-mins, at least sometimes. So the setup is this. Suppose you have C being a critical point for F. And by that I mean the derivative is 0, so it's a possible local max or min. So how do we tell? Well, if the function happened to be concave up, oops, let me try that again. If the function happened to be concave up and the critical point was here, then you would see that you would have a local minimum. And if the function happened to be concave down, and this was the critical point, you can see that you would have a local maximum. So the second derivative test is just going to say that if you have a critical point and the second derivative is positive, so here it means the second derivative at C will be bigger than 0, then you have a local minimum. Whereas if you have a critical point and the second derivative at that point is negative, and it's concave down, you'll have a local maximum. Now, the test is essentially inconclusive if the second derivative is 0. And the reason for that is, so inconclusive if the second derivative is 0. And the reason for that is sometimes if you have saddle points, inflection points like this, right, then those critical points will be saddles and they'll be neither max nor min. Okay, and that can happen sometimes when the second derivative is 0. But it can also happen that the second derivative is 0, but it's not an inflection point. So for instance, if you have f equal to x to the 4th, the graph looks like this. And you see it will be a local minimum. But the second derivative, so the 4 and the 3 come down, so you get 12x squared. Well, the second derivative at this point, so that point is 0, is 0. And you can't tell really the difference between the second derivative being 0 here, and where it's neither max or min, or second derivative being 0 here, when it really is a local max or min. And so, because of that, we just rule out the test. If the second derivative is 0, you just don't use it. But anyway, here's the statement. So this is the second derivative test. It's important that you know that you're assuming that the point C is a critical point where the derivative is 0. So that has to be true, or this test is just nonsense. 1. If the second derivative at C is bigger than 0, you should think to yourself, well, that means concave up, which means it has this shape. Then you see you have a local minimum. 2, if f double prime at C is negative, you should think to yourself, negative means concave down, so it has this shape. And you can see that will be a local maximum. And 3, if f double prime at C is 0, you get no information. Try something else. Right? It might be a max, it might be a min, it might be neither. You just can't tell with this test. All right, we'll do an example in the next video. Ciao.